class. Today let's study about continuity. So before going into the mathematics definition of continuity, we will use continuous in our daily life. Suppose someone is asking from how much time you are working. You will be saying like I am continuously working for 3 hours. What is mean by continuous at there? So what is mean by continuous at there? Like you are working non-stop without any gap or any break, right? Same wise in continuity also or continuous function also, the graph of function will be continuously, which means it does not have any break or gap or any jump in the graph, then it is called as continuous function. So what is mean by continuous function? A function a graph of a function in which it does not have any break or jump is called as continuous function, right? So like in this continuous function, like we can easily find out like this is definition. So how to find in a graph, like how it is continuous or not. Like if we draw the graph and without lifting the pen, continuously we are moving but we are not lifting the pen, then it is called as continuous function. So how we can find whether it is continuous or not? If we draw the graph without lifting the pen, then it is called as continuous function. Now let's see some examples. F of x is equals to sin x. Right? How the graph will be? It will move from negative infinity to positive infinity and 0 and then to infinity. Like I am not lifting the pen, right? So it is continuous function. Continuous function. Right? So at here, now let's see, you have studied limits. Now see how limit will be at this point, at 0 point. So now LHL of x is equals to 0, what will it be there? So I am moving x from 0 minus, like from negative side of left hand side of 0 I am tending to 0. Then how the function f of x is tending? Right, 0. So LHL will be 0, right? And at here from right hand side, if I tends to 0, f of x is also tending to 0. And RHL is also 0, right? And what is f of 0? F of 0 is also 0. So for this function, LHL is equals to RHL is equals to f of 0. Right? Now let's see another example. F of x is equals to tan x. Right? So how graph will be there? So right, like this, the graph will break at right pi by 2 and say right 3 pi by 2. So at all odd multiples, tan x is not, tan x will break. Like see, it is continuous from minus pi by 2 to it's moving, and at pi by 2 I need to break and I jump here, which means we are jumping and marker is lifting, right, while drawing the graph. So it is discontinuous at odd multiples of pi by 2. So f of x is discontinuous at 2n plus 1 of pi by 2. Now let's see limits at this point. So limit x tends to pi by 2 minus. So what will be the f of x? See? So from left side I am turning to pi by 2. How the graph will be going to? Right. Plus infinity. So plus infinity. Whereas RHL, right, from right side I am turning, it is going to minus infinity. So RHL is minus infinity. So, and here f of pi by 2 not defined. So see this, at f of x it is discontinuous at pi by 2 and the limits LHL and RHL are not equal, and also f of pi by 2 is not defined. So LHL is not equals to RHL, right? So now let's see another example. F of x is equals to x square minus 9 by x minus 3. So how the graph will be there? At x is equals to 3, it is not defined, right? If x is equals to not 3, it is not defined, and the remaining will be right. It will be x plus 3 for x not equals to 3, right? So the graph will be like this, but so now how the graph will be? I will be like this. At 3 it won't be there, and then it continuously moving, right? So the graph breaks at x is equals to 3, right? It is breaking. So it is not continuous at x is equals to 3, and discontinuous at x is equals to 3, right? Now let's see our LHL at x is equals to 3, right? So when x tends to 3, it tends to, right, 6. Like see, limit x tends to 3 minus f of x, that is x square minus 9 by x minus 3, right? So limit x tends to 3 minus x plus 3 into x minus 3 by x minus 3. So 6. LHL is 6. Same wise RHL, limit x tends to 3 plus x square minus 9 by x minus 3. So limit x tends to 3 plus x plus 3 into x minus 3 by x minus 3. It will be also 6. So in this case, see, LHL is equals to RHL, but it is not equals to f of 3. Because why? Because f of 3 is not defined. And f of 3 not defined. So now see, let's see another example. So in this, x square minus 9 by x minus 3 for x not equals to 3, and 3 if x is equals to 3. So in this same graph will be there. So LHL and RHL are 6. So how the graph will be there. So see in this question, the graph will be same like this with a small change. So the graph will be like this. But what will be? X is equals to 3. Right? 6, 3. X is equals to 3. Right? So here also we are lifting the pen. So and here also we can see that it is not continuous at x is equals to 3. And we know that we have already calculated LHL and RHL for this function. So at x is equals to 3. So LHL is equals to RHL is equals to 6. And f of 3 is equals to 3. Right? Here, what you can observe from this example, see, if LHL, RHL and f of function, value of function at that point, all are equal, then it is continuous. But if one or two tends to infinity, then it is discontinuous, right? And f of x and LHL or RHL is equal, but f of a is not defined, then also it is discontinuous? No. If LHL and RHL are equal and f of a also defined, but it is not equals to f of a, then also we can see it is discontinuous. So overall, what will be the mathematical definition of continuity of a function? Now let's see. So with these examples, we have concluded some points. So now the conclusions, what are the conclusions we have got? That for a function f of x to be continuous, at x equal to a, then f of a should be defined, right? Second, left hand limit and right hand limit at that point at x is equals to a should be defined and equal. What is meant by LHL is equals to RHL? We know that if LHL and RHL are equal and defined, what is meant by that? Limit exists. That is, limit exists at x is equals to a. Now, what is third point? LHL is equals to RHL is equals to f of a. If limit value and value of that function are equal, then it is called as continuous at x is equals to a. So these are the conclusions we have got from those examples, right? Now, what is discontinuous function? How much time?
15 minutes.
If I start discontinuous, then it will be there. Insert that, let's take a small example and complete it. Now, let's see some examples of continuous and discontinuous function. So, f of x is equals to sin square x plus cos square x, right? So, see in this function, sin square x plus cos square x is always 1 for all over R. So, for all x x belongs to R, right? So this is what constant function. So it is continuous. Right? Continuous for all x belongs to R. Now let's see another example. F of x is equals to sec square x minus tan square x. Now you will say, ma'am, sec square x minus tan square x is also 1. So therefore it is continuous for all x belongs to R, right? No. See, sec x and tan x are defined in pi by 2? No. 3 pi by 2? No. So this is equals to 1, but when x belongs to R minus 2n plus 1 pi by 2. Right? So, for this R minus 2n plus pi by 2 points, f of x is continuous, but it is discontinuous. Right? X is equals to 2n plus 1 of pi by 2. We should see, like here also sin square x plus cos square x is 1, but for all x is equals to R. Whereas this identity follows when x belongs to R minus 2n plus 1 of pi by 2. So we should see that whether in which conditions it is following the identity, right? Now let's go to another. F of x is equals to 1 by x square plus 1. Right? So, for this function to be discontinuous, like the only problem we have is that this can be 0. If that is 0, then we will get discontinuity. Otherwise, it is always continuous, right? But see whether x square plus 1 can be 0. No, right? X square is minus 1. For any real value, x square is not equals to 1. So, this will be always, won't be, never be 0. Right? Therefore, f of x is always continuous. Always continuous. Now, see. F of x is equals to sin of x minus c. Right? Here, what you will say? Say, right. So, for sin is defined for every value of r. Every value of r it is defined, right? So, it can be x minus a, x plus a or anything. Whether it belongs to r, then it is continuous, right? Hence, continuous. And let's see one example again. F of x is equals to 1 by minus 2x. So what you will say? The possible discontinuity is whether this will be 0. Is it possible for 1 minus 2x to be 0? Yes, ma'am, we can do it. See, 1 minus 2x is equals to 0, 2x is equals to 1, so x is equals to 1 by 2. So what we can say? At x is equal to 1 by 2, function will become undefined, that is in, right? So, f of x is discontinuous and x is equals to 1 by 2. So, for continuous and discontinuous, we need to check whether in the given domain it is always possible for the function to be continuous or is there any break, right? So for today, let's conclude this lecture and in the other lecture we will see the other topic. Thank you.